So try not to let the variables in these problems scare you or overwhelm you as they're different than yesterday. Remember, variables are just numbers. So they behave the same way numbers do. Okay? It's just that we don't know what the number is. It's allowed to change. But variables are numbers. They represent numbers. So in this question, we're going to deal with the number individually from the variable. So first we're going to think about the cubed root of 125. Remember, a cubed root is asking what times itself 3 times is that number. So what can I multiply 3 times to get 125? 5. So the cubed root of 125 is a nice clean number, so the cubed root of 125 becomes 5. Now the cubed root of y to the 6th. What does y to the 6th mean?
Y times y.
Right, that we're multiplying 6 y's together. And if a cubed root is asking, what do I multiply 3 times, then I could kind of group these up in groups of 3. How many groups of 3 do I have? 2. So that makes a y squared when I take the root of y to the 6th. So 5y squared is my final answer. It may become annoying to have to write out multiple y's or x's or whatever in a problem if, say, we had like y to the 54th. So here's another way to think about it. When we learned about fraction exponents in our first lesson for this chapter, how did we write that fraction exponent? Like, how could I take this question and make y to some power? Y to the 6 thirds. The top is the power, the bottom is the root. What does 6 thirds reduce to? 2. So you can just take your power and divide it by the root, and that will be your new exponent. Okay? So visually, you can kind of see what's happening when you write out the 6 of them and group them up in groups of 3s. But when we talked about those fraction exponents, we said the top is the power, bottom's the root. So you do 6 divided by 3 and get 2. So we have y squared. What do we do when we have a power outside of a group like this? Distribute, give it to everything inside. So I have 9 to the 1/2. U to the, what do I do when I have power to a power? Multiply it. So 2 times a half is 1. So u to the first, you can write the 1, not write the 1, it doesn't really matter. And v to the 5th. We're almost finished, but 9 to the 1/2
is 3.
What is a 1/2 power the same as?
Square root.
A square root. Remember, top is power, bottom is root. So we can write that 9 to the 1/2 as the square root of 9, which is 3. So I get 3u v to the 5th. Questions? That's the answer for that one. Next. Oops. On this one, this is kind of like our first question that we have a root and numbers. So with the numbers and variables individually, one at a time. So 5th root of 5. What do I multiply 5 times to get 5? It's not something pretty, right? Students always want to say it's 1, but 1 times 1 times 1 times 1 times 1 is not 5. It's still just 1. So 5th root of 5 is not pretty, so it just is going to have to stay the 5th root of 5. In that first example, we said we can take powers and divide them by roots to simplify them. So I have a to the first, and it's no longer under the root, so I'm going to put it in the front of this thing. I like putting my stuff that's not under a root in the front instead of in the back, because otherwise sometimes it kind of starts to look like it's still under the root if we're not really careful with how we're writing it. So I like to put it in the front so we can clearly see that that is not under the root anymore. So 5 divided by 5 is 1. Now we've got a problem here with b, because 5 does not go evenly into 9. So let's draw out our picture again and see what happens. So if I have 2, 3, 4, 5, 6, 7, 8, 9 b's, and this is a 5th root, so we're thinking about stuff that multiplies 5 times, so I could group up 5 of these b's. I've got one group that's all set, so I can take one b outside. But I have 4 of them that I can't group up, so those 4 of them are left over and have to stay inside. So when I group up from those 9 B's, I can group up 5 of them, take care of the group, bring it outside. But I can't group up those 4. I don't have enough, so those leftovers have to stay inside. So with C to the 13th, how many groups of 5 are there in 13? 2 groups of 5. And how many are left over after I take out those 2 groups of 5? 3. The remainder is 3. So if I do 13 divided by 5, I get 2. So 2 come out with a remainder of 3, so 3 stay in. And this is our final answer. Now it seems kind of strange because the directions say simplify, and that does not look more simple than the original question, right? But remember, the goal of simplifying is that we want less stuff under the root. So our final answer does have less stuff under the root. So it doesn't look more simple because it's longer than the original question, but there's less stuff under the root, so that is more simple. Yesterday, when we were getting ready to do our fraction problem, I warned you that it would be the longest one of the assignment, and just beware, once again, this is going to be the longest one of our assignment. So, when I do a root of a fraction, what's my first step? Split it up. So I get the cubed root of x over the cubed root of y to the 7th. That y to the 7th, when it comes up, that y to the 7th can be simplified. Wait for it to catch up. There it goes. Okay, that y to the 7th can be simplified. As we did in the last question, how many times does 3 go into 7 evenly?
2.
2. So y squared can come out. What's left over?
1y.
1y. So 1y is stuck inside. What's the problem with this? Why is this not our final answer? Because there's a root on the bottom. And we're not allowed to have a root on the bottom, so I need to fix it. We fix it by multiplying by it. So I'm going to multiply by the cubed root of y. I don't need to multiply by the y squared because that's not a problem. But that cubed root of y is a problem. How many cube roots does it take to cancel each other out? 3. A cubed root, we need 3 cubed roots to cancel each other. So I've got 1 in the original question. I need 2 more. So I've got 3 cubed roots total. 1 from the original question, multiply by 2 more gives me 3 total. Multiply by the same thing on the top as you do on the bottom, so we're really just multiplying by 1. So on the top, I have the cubed root of x and y squared. On the bottom, I've got these cubed roots of y, 3 of them. So they all cancel each other out to just give us just y. So the 3 cubed roots of y cancel to give us y, but there was already a y squared down there, so I've got y cubed all together. And that's our final answer. Okay. Questions?
So after you split it up, and
Yep.
then on the top, why would it be like the x cubed or whatever?
Cubed root of x on the top?
Yeah. Because wasn't it supposed to be like? Because on the other problems that we did, where it's like that, wouldn't you have the same thing that's on the bottom be on the top?
When we multiply. So when I multiplied over here, when I chose what to multiply by, I multiplied by the same thing on the top and the bottom. But that first step, I was just splitting, separating. The top gets its own root, the bottom gets its own root.
Okay.
But when I choose to multiply, I need to make sure I'm multiplying by the same thing on the top and the bottom. Guys, please be quiet.
Why is there y cubed at the bottom?
I got a y from multiplying all of those cubed roots of y together. So multiplying 3 cubed roots of y gives me a y. but I already also had a y squared out there, so y squared and y make y cubed.
Okay. Oh, yeah. Okay.
So since you multiply 3 cube roots of y, you just get a single.
A single y.
Oh.
Yep, 3 cubed roots of y makes a single y.
So if it were 5 cube.
If it were 5 cubed roots of y, we'd have something a little bit different. But if this is 5/5 roots of y, then we would just get a y out of it. And the number that we have matches the type of root, then it just cancels out.
Can you explain this step after you split them up?
So after we split them up, this step right here in purple, okay. That step after we split them up, I just worked on the bottom. I left the top alone, and on the bottom I said we could do that division and say 3 divides into 7 twice, so I could bring 2 of the y's out with a remainder of 1, so there's 1 left over. That's like on the last problems where we looked at writing out 7 y's, and we're making groups of 3, so I have 2 groups of 3 with 1 guy left over. So the y squared came out, and 1 y was left in. Okay?
But then why did you multiply it only by?
Just by the cube root and not the y squared? Because the y squared isn't a problem. Y squared's allowed to stick around on the bottom. We're just trying to fix that root. All right, so like yesterday, after we had our longest problem, let's look at this problem. If I have 5 square roots of y plus 6 square roots of y, then what do I have?
11.
11 square roots of y. Okay.
Yeah, it's longer than.
Whew. Okay, so refresh ourselves after that last problem. We can do this, though. And we have one more example to talk about. All right, we cannot add or subtract roots that are different. These roots have different things inside of them, so we cannot combine them yet. What we need to do is simplify them individually and hope that they turn into the same thing. So we're going to simplify the first one. That 3's out front. Cubed root of 5. What's the cubed root of 5? Not pretty. So cubed root of 5 is just going to stick out. The 3 goes into 5. Remember, we can take the power divided by the root. 3 goes into 5. How many times evenly? 1 time evenly. So 1x comes out. How many are left over? 2. For the second one, so that simplifies our first one. For the second one, we need to think about simplifying the cubed root of 40. So I'm going to just kind of take that off as a side note here and work on the cubed root of 40. When we simplify a cube root, we're looking for a perfect cube that divides into it. So remember, perfect cube is something that we multiply 3 times to get. So it's a perfect cube that goes into 40. 8 is a perfect cube that goes into 40. 8 times 5 is 40. What's the cubed root of 8? 2. So cubed root of 40 turns into 2 cubed roots of 5. Can I do anything with that x squared that's inside of there?
No.
Why not? Because 3 doesn't go into 2, so there aren't enough to fix anything. So on the outside now I have a 2 from that 40 that we fixed, and an x that was already there in front of the original thing. Cubed root of, on the inside I have the 5 from the 40, and the x squared that we couldn't do anything about.
Wait, what? Wait, why is there an x on the outside?
Because there was originally an x on the outside. So that x on the outside is just getting copied down from the original question. The 2 is outside from the 40. The 5 is inside from the 40. And the x squared is inside from the original question. Do the roots match now? Yes, they do. So I've got a cubed root of 5x squared and another cubed root of 5x squared. So if I have 3x of something minus 2x of something, what do I get? 1x of that something. And that's our final answer.
Will they ever give us a problem that is like undoable?
No, if they tell you to simplify and it's one of these addition or subtraction problems, it should always be able to become the same thing. There won't be any trick questions like you simplify them down.